This time, guys, we're doing real stoichiometry with real chemicals, but the concept's the same. So hopefully it's not any more difficult for you. So I picked a reaction that we did with the indicator in your lab, in your Measure Me and Mole lab before, we could have done before we left. So this is hydrochloric acid and sodium hydroxide. It's an acid-base reaction. It's a specialized double replacement. So you get water and sodium chloride. So what's different here now is that you've actually got to add molecular masses of your compounds. So hydrochloric acid, you get that mass by adding the mass of hydrogen and chloride. Same thing for sodium hydroxide. Sodium plus oxygen plus hydrogen. That's where your 40 comes from. Water, 2 hydrogens, 1 oxygen. Sodium chloride, 1 sodium, 1 chlorine. We were doing this before break. So your masses are up in parentheses, but in some of the problems that I will eventually have you work, you're going to need to add masses. You can't forget that skill. So I'm assuming here we start off with an 8-gram sample of sodium hydroxide. Oh, doing a rice table, we need moles. So if I've got 8 grams of sodium hydroxide, oh, I know 1 mole is 40 grams, so I've got 8 grams, 40 grams is 1 mole, I've got 0.2 moles. I can start filling out my table. So if I've got 0.2 moles of sodium hydroxide, this is a 1-to-1 to 1-to-1 reaction. So as far as figuring out pieces, this is an easy one because I'm going to need the same amount of pieces to react with my sodium hydroxide, and I'm going to get the same amount of pieces on the backside. So that's great. So I know I need 0.2 moles of hydrochloric acid to react with my 0.2 moles of sodium hydroxide. So when I change, my change line is exactly the same. So I'm going to lose 0.2 moles of each, and I'm going to get 0.2 moles of each one of my products. That's what 1-to-1 to 1-to-1 means. So when I get done, I'm going to wind up with 0.2 moles of water, and I'm going to wind up with 0.2 moles of salt. So when I want to figure out how much water, and poop. See, this is the bad thing about video, is I don't have somebody in the classroom yelling at me, you wrote it wrong. So for how much water and sodium chloride I made, well, how many moles did I make? And then you multiply it by the molecular mass, and there you go. And then because when you do a reaction, you don't get to put moles on a scale. You do, but that's not what you're figuring out. You're going to take the mass in grams, and you just have to know what that moles are. This is the calculation you're going to do. Oh, I know I'm going to need that mass of hydrochloric acid. We're actually going to do molarity, but we'll talk about that later. So I know I need 7.3 grams of hydrochloric acid to react with that mass of sodium hydroxide I started with. So my numbers come out. So if you like the rice table and you like seeing the visual of the change, there you go. You've saved your math until the end. Once you've figured out your initial moles of one of your starting materials. Once you've got a balanced equation, you can unlock the key to the rest. A certain sneaky teacher might, in addition to making you figure out how much stuff you could make, might make you balance the equation at times before you solve the rest. I may or may not do that. So, if you want to see it the old school math way, here you go. Again, some things you should notice. One of the things you should notice is that the first step in all of these problems is completely identical. And again, it should look like the first step that you have to fill out for the rice table, because you need to convert your starting material of something into moles. So boom, boom, boom. Looks exactly the same. Your second step, you're saying, wait a minute, you're making a comparison. You're saying, okay, I've got moles of sodium hydroxide. I either need to turn it into something or react it with something. What's it going to go with? So in the first line, saying, oh, 1 mole of sodium hydroxide is turning into a mole of water. In the second one, 1 mole of sodium hydroxide is turning into 1 mole of sodium chloride. And guys, I did the same thing here. Oh, no, I didn't. What am I talking about? Losing my mind. This one, 1 mole of sodium hydroxide is going to react with 1 mole of hydrochloric acid. But the same idea is you need to make sure you're converting moles of what you're starting with into moles of whatever you need it to turn into or react with. The final step is a reverse, saying, okay, I'm in my correct material, I need to flip moles into grams. Get rid of that label. And you'll notice your math all turns out the same. So 8 times 1 times 1 times 18 divided by 40. And it's just ones in the bottom, you don't need it. 8 times 1 times 1 times 58.5 divided by 40. 8 times 36.5 divided by 40. So exact same answers, exact same concept. How do you like to work? Okay. Got one more I'm going to show you, this time without one-to-one numbers. When you do your problem sets, understand that you're not going to even get 1 to 2s. Sometimes you're going to get 1 to 3s or 2 to 5s. Okay? It's all okay. It's just math. It's just math, and you can practice it. Okay? It's not bad. You're almost there. One more set.